Hello everyone. In this tutorial, we are going to provide a solution to this interesting exponential equation. Don't forget to like, comment, and subscribe. Let's get started. We're asked to solve the equation the x root of 2 divided by x minus 1 equal to x minus 1 to the power of x minus 2. Alright, you should know that x cannot be equal to 1 because if x is 1, we have 1 minus 1 here, which is 0, and the whole system is said to be undefined. First of all, I would like to transform this root into 2 divided by x minus 1 to the power of 1 over x, all the same. So we have 2 divided by x minus 1 raised to the power of 1 divided by x. This is equal to x minus 1 raised to the power of x minus 2. All right. Next, I would like to distribute this exponent upon the numerator and denominator. Let's do that. So we have 2 raised to the power of 1 divided by x divided by x minus 1 raised to the power of what? 1 over x. This remains x minus 1 raised to the power of x minus 2. Now let us multiply both sides by this denominator in order to cancel the fraction. So to the left hand side we have 2 raised to the power of 1 over x. This is equal to x minus 1 raised to the power of x minus 2 multiplied by x minus 1 to the power of what? 1 over x. You see the bases are the same. We are free to add the exponents according to one of the laws of indices. So this is 2 raised to the power of 1 over x equal to a base, which is x minus 1, to the power of x minus 2 plus 1 over x. Next, I would like to multiply both exponents by x. If you multiply this by x, you have to multiply the whole of this by x, so that this x will cancel this x. To the left hand side you have only 2, and this is equal to x minus 1 raised to the power of what? X times x will give us x squared. X times negative 2 will give us negative 2x, and x times 1 over x will give us 1. Pay attention, this is a perfect squared quadratic expression because the coefficient of x is negative 2. If you divide it by 2, you get negative 1, and negative 1 squared will give us this 1, and hence it is a perfect squared. So now let us rearrange this equation. We have 2 to the left. This is equal to x minus 1. And to factorize this, you take an x, then you add half the coefficient of x. Half of the coefficient of x, which is negative 2, will give us negative 1. Everything to the power of 2. Another thing you should know about a constant number, any constant, provided it is a positive number, it can be expressed as the square root of that number squared. This is always equal provided this number is positive. And hence we can write 2 as the square root of 2 but raised to the power of 2. You know, subsequently this 2 can neutralize the square root, and we have our 2 back. And this is equal to x minus 1 raised to the power of x minus 1 raised to the power of 2. And I'm going to repeat the same thing because I can see that we have another 2 here, which is the exponent. I can write it as square root of 2 whole squared. So we have square root of 2 raised to the power of square root of 2 again, whole squared. This is equal to x minus 1 to the power of x minus 1 to the power of 2. All right. Now let us relate the left and the right hand side. These outermost powers of 2 can cancel, and if you relate the base and the exponent, they are equivalent, right? You can either relate this to this or this to this, all the same, which implies that x minus 1 is the same thing as the square root of 2. And if you take negative 1 to the other side, it becomes positive 1, and hence x equal to the square root of 2 plus 1. And this is said to be the solution to this problem. I would like to give you an assignment. Take this x equal to square root of 2 plus 1 and plug it into the original equation. This is the original equation. Wherever you have x, replace it with square root of 2 plus 1 and see whether the left and the right hand sides are equal. Thank you for watching. Do share to your learning colleagues. Bye-bye.